The National Electrical Code, Section 250.118 outlines what can be used as grounding electrode conductors. Firstly, metal underground gas piping systems are permitted. Secondly, metal underground water piping systems can be used. Thirdly, metal fire alarm cable can be utilized. Fourthly, concrete encased electrodes as per section 250.52. A4 are acceptable. Fifthly, grounding electrodes as per section 250.52. A5 through A8 are allowed. Sixthly, other listed grounding electrodes can be used. It is important to note that listed grounding electrodes include, but are not limited to, the metal frame of a building or structure and other electrodes as recognized in section 250.52. Section 250.52 specifies the materials that grounding electrodes should be made of, including copper, copper-clad steel, iron, iron-plated steel, or other metal that is not subject to rapid deterioration from corrosion. Common examples of such materials include 1. Pipe rigid, intermediate, or electrical metallic tubing not smaller than 1/2 inch internal diameter. 2. Conductors as defined in section 300.3. 3. Grounding ear-on service equipment enclosures. 4. Concrete encased electrodes as described in section 250.52. A4. 5. Driven electrodes as described in section 250.52. A5. 6. Ground rings as described in section 250.52. A6. 7. Plate electrodes as described in section 250.52. A7 and A8 rod electrodes as described in section 250.52. A8. The National Electrical Code section 250.56 addresses grounding electrode conductor connections. Grounding electrode conductors must be connected to grounding electrodes by exothermic welding, listed pressure connectors, listed clamps, or other listed means. The definition of a joint in this context is not specifically defined in the National Electrical Code. However, it is generally understood to mean any point where two or more conductors are connected together. The National Electrical Code does not specifically address the use of a structural beam as a grounding electrode conductor. However, the code does allow for the use of other listed grounding electrodes. Therefore, a structural beam could be used as a grounding electrode conductor if it is listed by a recognized testing laboratory. It is important to note that the grounding electrode conductor must be connected to the structural beam at each joint. This is to ensure that the grounding path is continuous and that the structural beam is properly grounded. When considering a structural beam as a grounding electrode conductor, several factors must be evaluated to ensure compliance with the National Electrical Code and to provide effective grounding. Firstly, material compatibility is crucial. The structural beam must be made of a material suitable for use as a grounding electrode, as specified in section 250.52. Materials like steel or iron are commonly used, but they must not be subject to rapid deterioration from corrosion. If the beam is made of a material prone to corrosion, it may not be suitable as a grounding electrode conductor unless properly protected. Secondly, the listing and approval are essential. For a structural beam to be used as a grounding electrode conductor, it should be listed by a recognized testing laboratory. Listing indicates that the beam has been tested and found to meet specific safety and performance standards. This ensures that the beam is suitable for grounding purposes and meets the requirements of section 250.118. Thirdly, the continuity and connections need to be continuous. Because the question mentions multiple joints, it is important to guarantee electrical continuity throughout the entire length of the beam. Section 250.56 mandates that grounding electrode conductors be connected to grounding electrodes using approved methods such as exothermic welding, listed pressure connectors, or listed clamps. Each joint must be properly bonded to ensure a low impedance path to ground. If the joints are not adequately connected, the grounding path may be compromised, reducing the effectiveness of the grounding system. Fourthly, the size and capacity need to be checked. The grounding electrode conductor, in this case, the structural beam, must be of sufficient size to handle the ground fault current. The size is determined based on the size of the service entrance conductors, as specified in section 250.66. If the beam is not large enough to carry the potential fault current, it may overheat or fail, posing a safety hazard. Fifthly, the grounding electrode system. It is crucial to ensure that the structural beam is properly connected to a grounding electrode system that meets the requirements of section 250.50. This may include connection to a ground rod, ground ring, or other approved grounding electrodes. The grounding electrode system must provide a low impedance path to earth to effectively dissipate fault currents. 6. Accessibility for inspection and maintenance. The connections and the structural beam itself should be accessible for periodic inspection and maintenance. Connections can loosen or corrode over time, so regular inspections are necessary to ensure that the grounding system remains effective. If the connections are not accessible, it may be difficult to identify and correct problems. 7th, corrosion protection. Corrosion can significantly degrade the effectiveness of a grounding electrode conductor. Steps should be taken to protect the structural beam and its connections from corrosion, especially in environments where corrosion is likely to occur. This may involve applying protective coatings or using corrosion-resistant materials. 8th, documentation and labeling. Proper documentation of the grounding system is essential for future maintenance and troubleshooting. The location of the grounding electrode connections and the routing of the grounding electrode conductor should be documented and labeled. This information can be invaluable for electricians and engineers who may need to work on the electrical system in the future. 9th, compliance with local codes and regulations. In addition to the National Electrical Code, local codes and regulations may impose additional requirements for grounding systems. It is important to be aware of and comply with all applicable codes and regulations. This may involve obtaining permits or inspections from local authorities. 10th, professional consultation is recommended. Given the complexity of grounding systems and the potential safety implications, it is always advisable to consult with a qualified electrical engineer or electrician before using a structural beam as a grounding electrode conductor. A professional can assess the specific application and ensure that the grounding system meets all applicable codes and standards. Regarding the specific question about joints, it is important to clarify what constitutes an acceptable joint in this context. A joint refers to any point where two or more sections of the structural beam are connected. These connections can be made using various methods such as welding, bolting, or using mechanical connectors. Regardless of the method used, each joint must provide a reliable electrical connection to ensure continuity of the grounding path. If the joints are welded, the welds must be of high quality and properly inspected to ensure that they provide a low resistance connection. Bolted connections must be properly tightened and protected from corrosion. Mechanical connectors must be listed for grounding purposes and installed according to the manufacturer's instructions. In situations where the structural beam is not listed as a grounding electrode, it may still be possible to use it if it meets certain conditions and is approved by the authority having jurisdiction. The authority having jurisdiction is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, an installation, or a procedure. The authority having jurisdiction may require additional testing or documentation to demonstrate that the structural beam is suitable for use as a grounding electrode conductor. They may also require that the grounding system be inspected and approved by a qualified third party. When using a structural beam as a grounding electrode conductor, it is important to consider the potential for stray currents. Stray currents are unwanted electrical currents that flow through unintended paths, such as the grounding system. These currents can cause corrosion, interfere with electronic equipment, and pose a safety hazard. To minimize the risk of stray currents, it is important to ensure that the grounding system is properly designed and installed, and that all electrical equipment is properly grounded. It is also important to regularly inspect the grounding system for signs of corrosion or other damage. In summary, Using a structural beam as a grounding electrode conductor is possible under certain conditions, but it requires careful consideration of several factors, including material compatibility, listing and approval, continuity and connections, size and capacity, the grounding electrode system, accessibility for inspection and maintenance, corrosion protection, documentation and labeling, compliance with local codes and regulations, and professional consultation. By following these guidelines and consulting with qualified professionals, it is possible to design and install a grounding system that is safe, effective, and compliant with all applicable codes and standards.